It only takes a few minutes in your regular microwave oven to heat up this microwave kiln to temperatures hot enough to fuse glass or even melt metals. Before I show you how to make a microwave kiln, let me better explain what it is. Microwave kiln is a kiln, but it doesn't use gas or wire heating element to heat up. Instead, it uses microwaves. Inside of the microwave kiln, you'll find silicon carbide. Silicon carbide absorbs microwaves, thus heating up to very high temperatures. Microwave kilns are probably most popular between people who fuse glass. You can turn pieces of glass into amazing jewelry, but that's not all. There's so much more you can do with a microwave kiln. You can fire ceramics, and you can even burn out wax or PLA from plaster molds when doing metal casting. And yes, you can melt metals. But that's for another video, because there's a better way to do it than using just a microwave kiln. In this video I'll demonstrate how to make a small 3-piece microwave kiln. And at the end of the video I'll show you some other kilns I made and tell you how they differ. You will need to make a plaster ring. To do that you can make a mold from EVA foam and then fill it with plaster. If you have a 3D printer, you'll find links to different size molds you can print. You'll also find some affiliate links to materials I used and a link to this printer. It's important to make your plaster ring weak. It can vary from plaster to plaster, but in general you want your plaster mix to be quite watery. After 1 hour, the plaster is ready for the next step. Put it in a microwave on top of some paper towels. Microwave it until most of the moisture is gone. I know my microwave, so I don't touch it until the plaster is dry. Since you're doing it for the first time, you can always stop the microwave to wipe it down and make sure it doesn't get too hot. And by the way, this is not the way you normally cure the plaster. Microwaves will make the plaster weaker, but in this case, it's okay. You'll want to close one side of the ring with a lid, or something of that sort. Electrical tape works great because it's stretchy. If you use the 3D printed mold, just flip the base around and use that. You'll want to make a mark on the side of the ring. You'll see for what in a second. You'll need sodium silicate, also known as water glass. The one I have right here is 37%, but you can also use 40%. It's not gonna make a big difference. Here is cured sodium silicate with some food coloring added to it. As you can see, it looks like glass. You'll need to mix sodium silicate with water in ratio 1:2 by weight. In this case I used 11 grams of water glass and 22 grams of water. Then I put it in a small spray bottle. You will also need silicon carbide grit. Here you can see 3 different grit sizes for comparison. I used 80 grit silicon carbide, but different grit sizes will also work. Just make sure it's not too powdery like 400 or too coarse like 24 grit. First we're gonna wet the walls with water and let it soak for a minute. Then we'll coat them with silicon carbide grit. Use your finger to press it down. Then we'll spray some water glass and coat the plaster with another layer of silicon carbide. Make sure to press silicon carbide tightly together. You don't need to spray water glass after every layer, do it by the feel. Silicon carbide should feel wet, but not too wet. On average, I spray it every second layer. The mark I left with the permanent marker helps me to see when I have sprayed a full circle. That way, I don't overspray the water glass. When desired thickness is achieved, you can use a popsicle stick to remove the excess silicon carbide. Now we can remove the bottom. We'll tidy up the other side, press it down very well, and if necessary, spray some more water glass. Later in the video, we'll need some ceramic fiber insulation blanket, also known as cave wool. We'll use some now to insulate the ring and protect the microwave. Make sure to wear gloves and a respirator when handling it. We'll microwave the ring until it glows red. We'll take it out, remove the top blanket and let it cool. Once cooled, you should be able to peel off the plaster. If your plaster is too strong, when it cracks, it will also crack the ring. You'll need a piece of glass. A glass from a picture frame will do just fine. We're gonna pour some silicon carbide on top of the glass and we'll add some water. Then we'll use a drinking glass with a flat bottom to sand it. It should look like this. We'll spray a tiny amount of water and we'll sand the ring. In case you missed it, I sprayed water, not water glass. After dusting it off, I put it in a microwave to dry it. This is the point where you can spray some more water glass to make the ring stronger. Just don't overdo it. A quick microwave dry and our ring is ready. It weighs about 40 grams and is 4 mm thick. Here's a failed ring with too much water glass. The water glass bubbled up and cracked the silicon carbide. I cut 2 strips of ceramic fiber blanket. I parted one strip in half because I want to keep my kiln small. Then I cut one end of the strip in angle. I wrapped the ring and did the same thing with the other end. Then I did the same thing with the other strip. I used rubber bands to keep ceramic fiber from unwrapping. Give it a roll to make sure everything sits in place nicely. We'll use water glass again, but this time You don't need to add water. Instead, we'll add some food coloring. We'll glue the end of the strip to keep it from unwrapping. Pay attention, I'm not brushing it under the blanket, only on top. More on that later. I put it in a microwave to cure water glass. If you used food coloring, it will most likely go brown. If the rubber bands didn't break in microwave, now it's time to remove them. Next, we tightly wrap the kiln with a cling film. I cut off the excess plastic from the top and the bottom. We'll use the glass again, but this time to sand the kiln. Use generous amounts of water and start slow. Once the water is absorbed, you'll be able to move the kiln easier. As you can see, I have wrapped the table with a cling film to stop the glass from moving. Once sanded, it should look like this. Now we can microwave dry it. After removing the cling film, I covered the rest of the kiln with more water glass. I did it in 2 parts so the kiln wouldn't stick to the blanket. After microwave curing it, I did the other side. Until the kiln is ready, don't overheat it in a microwave when curing water glass. I'll tell you why later. I used a heat gun to heat up water glass and change its properties. Then I switched to a blowtorch. Using a heat gun is optional. If you have to choose one, choose blowtorch. Just make sure not to overheat the kiln in one spot. Some parts of the kiln will look like a popcorn ceiling. You don't want too much of this effect, so we'll sand it a little bit. I'll tell you why we're doing it later. I mixed the leftover water glass with water in parts 1 to 2. Then I brushed it on the kiln. After a quick microwave dry, I added another layer and dried it again. Then I cut one of the holes bigger. I sanded the top and the bottom again and microwave dried the kiln for the last time. Then I put it on top of 2 ceramic blankets so I could cut out the shape. I sprayed some water between the blankets so they would stick together better while I work on them. After covering the sides and top with water glass, it was microwave cured. This time I didn't use a cling film because we're sanding the blanket the flat side down. Cling film was used to hold the layers of fiber together. I decided to add some more water glass. And then the same procedure again, heat gun and a blowtorch. Or only a blowtorch. Then I got rid of the popcorn by sanding it. I covered it with 1 to 2 ratio water glass solution. After microwave drying it, it was sanded again. I used 2 packets of sugru to add silicone feet. After making sure it was straight, I let the sugru set for 24 hours. The same way I made the lid, but it's only a single blanket thick. That's it, our 3-part microwave kiln is ready. Here I have some glass from broken bottles. Let's fuse it. You don't want to put the glass directly on the base, or it will stick to it. We'll use these fiber paper sheets that are made for this purpose. Firing times will depend on your microwave and the size of your kiln. In this microwave it takes about 4 minutes to fuse the glass. I don't use gloves because the outside of the kiln is just warm. It will get hot after a few minutes, but by that time the kiln will be resting. Let's see how it turned out. Let's speak about the glass turntable. Should you use it? In some microwave ovens, glass turntable can absorb some of the microwaves, thus heating the kiln slower. It's especially true when the plate is hot. So here's the situation. You finish fusing glass and you want to use your kiln straight away. The kiln is still warm, so you think, alright, because it's warm, it will probably need less time in microwave to fuse the glass. So you put it in a microwave only to find out that it actually needed more time than usual. So what's happening? Turns out the glass plate was hot from previous use. Because it's hot, now it will start to absorb more microwaves. More microwaves it absorbs, hotter it gets. Hotter it gets, more microwaves it absorbs. Here's a quick demonstration. If you heat up the plate in one spot with a blowtorch, it will keep heating up in the microwave. It's good that I didn't need it. This 800-watt microwave can fuse the glass in less than 3 minutes. If I use it with a turntable, it will take closer to 4 minutes. A 1000-watt microwave would do it even faster. Of course, heating up the glass that fast is not always the best thing to do. In fact, sometimes it's better to turn down the microwave power to achieve better results. This 3-piece microwave kiln can be abused. Let me explain. A lot of popular microwave kilns are made similar to this one. In this kiln, silicon carbide is directly glued on walls. With time, because of heating and cooling differences of these materials, the silicon carbide will crack, and the kiln can also crack. That's why you don't want to open these kilns to cool them while they're still hot, because that's a quick way to crack them. This kiln is made differently. If you made a mistake and you want to cool the kiln as fast as you can just flip it on the side while it's still hot and it's not gonna crack. Because of ceramic fiber and water glass, kiln weighs less than a can of Coke. And the water glass, it's pretty hard. So why did we sand the popcorn pattern, and why did I say that it's better not to put any water glass between ceramic fiber sheets? Well, it's to prevent the water glass from heating up on its own and to avoid a possible microwave arcing. Just like with a glass plate, the water glass can heat up on its own and damage your kiln. Here I recreated the problem. The part that is glowing is not silicon carbide, it's water glass. As we discussed before, water glass kinda looks like glass. Add some weird popcorn patterns and you have increased possibility of microwave arcing and kiln heating up in random spots. That's why we use the blowtorch to make the kiln look more like stone and less like glass. It's also why I don't recommend brushing water glass between ceramic fiber blankets, because you won't be able to heat it up to make the water glass appear less glass-like. It doesn't mean that you'll always get this problem. Some of my early kilns have glued fiber sheets and popcorn pattern, and they work just fine, but you never know. That's why it's better be safe than sorry. Here's another popcorn-like kiln I made. As you can see, I didn't even bother to cut the sheet in angle. I have used this kiln quite a lot. I mainly use it to burn out wax or PLA from plaster molds. And as you can see, there are 3 large rings. But how do you fit it in a microwave? Well, you just flip the microwave on the side. And as you can see, there's actually space for even a bigger kiln. This is what happens when you don't use a fiber sheet. The glass has stuck to the bed. If you try to remove it, you will make a hole in the base. Well, actually it's not too bad, so let's make some more holes. What? I'm just showing you how easy it is to fix the base if it's damaged. A quick water sand on top of the glass and your base is good as new. Let's address 2 questions that people normally ask. Is it safe to cook food in a microwave that was used to fuse glass? I don't see any problems, at least with a kiln like this one. Of course, if you're planning to use the kiln a lot, it only makes sense to get a dedicated microwave. But if you just want to play around, it's okay to use the same microwave as long as you make sure it's clean, well ventilated, doesn't have any weird smells, and is not damaged. Which leads us to the next question. Can I damage my microwave? Let me answer with facts. In the last year, I made over 100 kilns. I'm not kidding. Here are some of my early prototypes. After trying more than 100 kilns, I can confirm that I broke 0 microwaves. The only thing I recall is burning the paint with a hot fire brick. In other videos, I'll show you how to burn out wax or PLA from plaster molds by using your microwave kiln. I'll also show you how to make your own crucible and how to melt metals in your microwave.